Welcome, everyone. We're about to have a chat with one of the live wires of modern statistics, Professor Ingram Olkin of Stanford University. First, let me introduce everybody. This distinguished gentleman here on my right is, in fact, Professor Ingram Olkin. And to my left, Allan Sampson. Allan was a 1970 doctoral student of Ingram Olkin's at Stanford University, and Allan is presently a professor and head of the Department of Statistics at the University of Pittsburgh. I'm John Kettenring, Executive Director of Software Technology Research at Bellcore. In fact, I was a student in Ingram Olkin's first multivariate class at Stanford University, and our paths have crossed quite regularly ever since, primarily in the Washington, D.C. area. Today, we're only going to be able to touch on a few highlights of Professor Olkin's career, and I just wanted to refer you for more details to a very nice article which has the very appropriate title, A Conversation with Ingram Olkin. And you can find this in a 1989 book, Contributions to Probability and Statistics, Essays in Honor of Ingram Olkin. Editors are Glaser, Perlman Press, and Sampson. Publisher, Springer Verlag. Let me just say a few things about Ingram's background as we get warmed up here. Ingram was born down the road in Waterbury, Connecticut in 1924. His bachelor of science degree in math was from CCNY in 1947. He then received an MA degree in math stat from Columbia in 1949, headed south to Chapel Hill where he received his PhD in math stat in 1951. He served on the faculties of Michigan State, Minnesota, and Stanford University, where he's been since 1961. Ingram has contributed to the profession in so many capacities. I'll just mention a few here for the record: as editor of the Annals of Statistics, as president of the IMS, as chair of COPS, that is the Committee of Presidents of Statistical Societies, and as the first chair of CATS. We have all these strange acronyms in statistics, as some of you probably noticed. CATS is the Committee on Applied and Theoretical Statistics of the National Research Council. In summary, Ingram is an esteemed educator, a renowned researcher, a people person, and perhaps above all, a statistical statesman. Ingram, let me begin our little discussion here by going back to 1961. The year that you moved to Stanford. What attracted you there, and how did this move impact your career?
Well, it's sort of interesting. I had a sabbatic in 1958, and at that time I was at Michigan State, and I had the sabbatic at Stanford, and just became involved in the excitement of what was going on at Stanford. And it was one of the few places where it was lively, exciting, everybody, the sense of camaraderie. It was just really a wonderful place. So in 1961, when the offer came, it was really just beyond belief that I shouldn't join that group. The other point that was really lovely there was that half of the faculty, or some such number, had joint appointments with other departments. So it was very natural when they asked me to join the department, half in statistics and half in education. It was just a natural move, and very, very nice. So I was excited by it. Also, in 1958, I had there were lots of visitors. Bob Beckhofer was a visitor. George Forsyth, who was who started the computer science department, had an office next door. So there was a lot of interaction with other people, and that was just wonderful.
Was there anything particular that was the cause of the joint appointment with the School of Education?
Well, because my field had been multivariate analysis, the education had a history of work in also psychometrics, had a history of work in factor analysis and in psychometrics. So it was very natural for for them to try to have somebody in multivariate analysis at that particular time. It was close to the things they thought of: regression, multivariate, psychometrics.
Who were some of your colleagues that were at Stanford at that time?
Well, Charles Stein was on the faculty, Herman Chernoff and Sam Carlin. Herb Solomon was on the faculty. Al Bowker had been chair, and it was just at the transition when he became dean of the graduate school, and Herb Solomon became chair. And I think actually the offer came when Herb had taken over. Jerry Lieberman was on the faculty, Rupert Miller, Lincoln Moses, Manny Parson, and then I joined them, and I think that was probably the faculty. I hope I'm not omitting anyone at the time. Kai-Lai Chung was also in the department when I first went there. He and I went there in 1961 together.
And what about the type of work you were doing at the time? Did it in fact just continue straight ahead as you went off to Stanford, or did you find all kinds of different stimuli once you arrived?
It's really hard to say. You know, in 1961, there really weren't that many books, and the faculty was involved in writing books. So, for example, Carlin was working on total positivity. A lot of the work that Charles was doing was started in that time. So faculty sat in on courses because everything that was being developed was really new. And it was really interesting. One would just attend lectures because that was the latest of what was going on. And it really was an exciting period.
Well, I remember from this class in multivariate analysis that you took that I was never quite sure what, I kept thinking you'd give us an exam now and then, but the one thing I do remember that you asked us to do was to meticulously write up the notes from each one of your lectures and then hand them in.
I would like to take credit for that idea, but actually I learned that from Sam Carlin a year earlier. And one of the points was that people were developing new theory, new material. And so having the students write it up and corroborating it was a way of getting a record of what was going on so that future students would have that also.
There's a set of multivariate notes that I remember seeing.
That's right. It ended up with various versions, but over the years it developed as a set of multivariate notes.
Well, I think actually in the end you did give some sort of an exam, but by that point I was really trying to figure out what was going on. It was really quite a struggle. The one thing I remember was that you were so excited about it. I knew it had to be interesting and good, whatever it was, but
it was probably an unsolved problem that I had, John.
Before I came up here, and I actually dredged up all those notes that I had taken so meticulously. It was fun to go back and read, because in fact a lot of the material that you were offering us at that time was way ahead of what was available from any other source. Mm-hmm. So you had a kind of a twist or a spin on multivariate analysis that I suspect had kind of come out of your experiences in Chapel Hill.
I think that's right. In fact, it was interesting because 3 of us taught multivariate analysis later on, shortly after that time, namely Ted Anderson, Charles Stein, and I. And the 3 courses were very, very different. Each one had sort of a slightly different point of view. And that's what made it very, very nice for students to be able to get alternative versions of the same material.
There were lots of students that have gone through Stanford. What was the size of the graduate student body when you got there? Do you recall?
Well, it's been fairly consistent. We used to take somewhere around 12 to 15 students per year. So over a 4-year period, the student body at the PhD level was approximately 50 students, 50 to 55 students. It's cut down a little bit now, probably more closer to 40 students in total. But over the history of Stanford, I think we've produced about 330 PhDs. And the first one was probably about 1952. So in a period of 45 years, we produced 330. So that's, you can get the average, roughly fluctuates 8, 10, 12 a year.
Now, when you went out there, Ingram, did you immediately start your ties with the School of Education?
Yes. I've been actually, well, the idea of joint appointments actually was due to Al Bowker. And he had various ideas about this. First, if a department of statistics will almost certainly be a small department. It's not going to be 60 people. You might have 10, 15, but relatively small. And so his idea was that joint appointments would increase the size of a department because each billet would be 2 people instead of 1. Furthermore, he felt that it would be an opportunity for departments, for the statistics department to have a liaison with each of these departments, and that in a sense, I'll use the word, they would be spies, that I don't mean it in a negative form, but they would watch over the quality and the standards of statistics in each of these other departments. And that has worked out very, very nicely. At one time we had, over the years we've had joint appointments with the medical school, approximately 3 people, electrical engineering, operations research, economics, earth sciences, education.
Philosophy?
No, we did philosophy, and we had one in psychology. So we've tried to actually spread around the personnel in different departments. Now, the other point was, when you asked about my working, the answer is that each of us had a 50-50 appointment, which meant that 50% of my salary came from a School of Education, so that there were obligations in both sides. And half-time appointments are never half-time. They're generally not 50-50, they're 75-75. So one might question whether the extra effort is worth it, so to speak. I have always found it definitely worth it. I mean, the educational field was really a very positive influence for me.
And did some of the students that were working with you in statistics then grab a hold of problems coming out of the educational field? And was there that type of cross-fertilization going on?
Well, there were 2 methods. One is we started a program of PhDs in what was called quantitative methods in educational research. And Rosita Sitgreaves was on the faculty with me. And we had several others in education. So we had a PhD program in the School of Education. Furthermore, each of the students would get a master's degree in statistics. And we'd have a lot of joint fertilization. But then also, some of the students in statistics worked on educational problems. So I've had, well, at Stanford, we've had several such. And right at this moment, Henry Brown is one of our PhD students in statistics, and he's a vice president at Educational Testing Service. And Paul Holland is one of our students, and also is now in an educational, is at the School of Education at Berkeley. So we've always had this. But not only with education, other people generated connections with economics or connections with earth sciences and so on.
You've actually had students that have gotten PhDs both in statistics and other students with PhDs in education. You've supervised dissertations in both areas.
Right. That's right.
So when you arrived at Stanford in 1961, now as I recall, you actually were married when you were well before you went out there. In fact, you were married and raising a family while a graduate student, I guess.
That's right.
Now. So by the time in 1961, then, how big was the family, and how was that transition for you?
I have to do some arithmetic there.
Okay.
No,
This wasn't supposed to be easy, Ingram.
That's it. One of my colleagues in the School of Education at every faculty meeting said, "Oh, well, you know, Ingram is not good with numbers." So, our oldest daughter was born while I was a graduate student at Chapel Hill in 1950. And then in fact, all of our children were born in different states. Our second daughter was born at Michigan State in 1953, and our third in California in 1959 when I was on sabbatic. So all three children were with us in 1961 when we moved there permanently.
You know, I was wondering, I'd like to switch to the present at Stanford. You have a strong belief in the training of young statisticians. I think you've used some of your own personal research grants to bring in visiting statisticians, young people in the summer. You want to say a little bit more about this?
Well, several years ago, it seemed to me that we were having a lot of trouble bringing women and minorities into the field. And I had conversations with the National Science Foundation and asked them if they would support two young, either women or minorities, at Stanford during the summer, and in particular about the fourth year postdoc. Because the fourth year is an important year. You come up for tenure after 6 years. And so if in the fourth year you can become involved with some of the people outside of your own home institution, it would probably be beneficial as a mentoring device. So the National Science Foundation said they'd like to try that, and they did. So I had about over a period of 3 or 4 years, we invited 2 or 3 people every summer. And it worked out very well. Namely, they did get tenure. Not only did they get tenure, but some of them became involved with a research project with some of the faculty. So it was very, very, very beneficial. Then later, NSF said, why don't you continue this? And so up to this day, we have 2, 3, 4 women, minorities, try to visit every summer. And many of them it's virtually changed their lives, because coming from a small place, a small institution, you don't go to many colloquia, you're somewhat isolated, and suddenly here's this vista of speakers during the summer. We may have 40 visitors, and there'll be a seminar every day, and the expansion of ideas and their involvement really, really has had an effect.
Ian, I'd like to just switch gears a little bit.
Yeah.
You do talk today on a history of meta-analysis, and we know that came out of some conversations you had with people at the School of Education, Nate Gage and others. Would you say a little bit more about what got you involved in that?
Yes, well, as you know, there are many, many studies in education. And this colleague, Nate Gage, who is a very close friend, he's an expert in the teaching of teaching methods. Right. Excuse me, I was about to say teaching of statistics, but teaching methods. And he approached me one day saying, you know, Ingram, that we've done hundreds of studies. A lot of them are not done like randomized controlled trials. There's a certain amount of diversity. Yet the evidence seems to be in one direction. And is there some way to put all of these together to give you stronger power, to be able to come up with some kind of definitive answer? And that was 1972. And then, so that got me started. And then Larry Hedges, a student of mine, we started working in that, and he did some meta-analysis. And then that's how we really started. And then subsequently, Larry and I continued to work in the field. And
How did Larry get involved with you in doing that? Was that some?
Pardon me?
How did Larry actually get involved with you in doing that?
Larry was one of the PhD students in the School of Education. And he had a science background prior to coming to Stanford, and was interested in education. And he was in this program with Rose Sitgreaves and myself, and when I was working on it, he was interested. We gave lectures, and then the two of us started working. He started working on the dissertation. We started working together on it.
And what motivated you to write the book? You wrote the book in 1985. And
Well, Larry and I had continued to publish individual papers. And between 1972 and 1985, there was this, this major event, in a sense, by Gene Glass, who coined the term in 1976 of meta-analysis. So we had started a little earlier, but then there was a flurry of work in meta-analysis, and by the early 1980s, about 1982, we thought that we had produced enough material and knew enough that perhaps we should put this down in writing and in a composite way. And in particular, we felt that the statistics was what was lacking. A lot of people wrote about meta-analysis not in the statistical sense, but we were trained statisticians, whereas most of the other people were not trained. They were trained in the policy issues of meta-analysis. So our book complements some of the books that were not statistical, and their books complement ours because we didn't discuss the policy issues. So, for example, in particular, the book Summing Up by Light and Pillemer is a counterpart of our book, a very nice one.
I'd like to jump back to earlier times. The first paper that you did on inequalities was the one on Chebyshev inequalities with John Pratt. Do you remember? Is that correct?
That's correct. Yes, I forgot about that. That's correct.
The next question was, I was going to ask you, do you remember how it came about, or is that pushing memory too hard?
Well, I was on sabbatic at the University of Chicago in 1955-56. I might say a word about that. Allan Wallace was chair at Chicago. And Allan Wallace had a Rockefeller, I guess maybe Rockefeller Foundation grant to invite faculty from other fields to learn statistics. So, for example, one of the people there was Julian Stanley, who is well known for studying gifted children. And I first met him there when he was taking statistics. So he had come from Johns Hopkins. But then they also invited 2 statisticians each year. And Don Darling and I spent the year 1955-56 at Chicago. And that was a very, very nice period. And I had an office next to John Pratt. And we used to talk a lot about different problems. And either he would ask a question, or I would ask a question. So I remember saying, John, is there an unbiased estimator of a correlation coefficient? And does there one exist? And John and I thought about it, and then we started working on it and actually wrote a paper on it. And the same thing happened. I had noticed that there were some Chebyshev inequalities that were univariate. And so I said, there must be a multivariate version. And so John and I would talk, and then we started working on setting up the problem.
And then how long after that did you meet Al Marshall? This was 55,
so that was 55, 56.
Yeah.
Then I went back to Michigan State, and I don't know how I had another. I guess the first time wasn't the sabbatic. I must have had to leave. Otherwise, people will begin to worry about the sabbatic policy. I did have a sabbatic in 58, 59 at Stanford. And it's interesting how random affects one's life, because I had an office right next to Al Marshall. Al Marshall got a PhD at the University of Washington in Seattle, with Bill Birnbaum. And his thesis was on multivariate Chebyshev inequalities. So that was 1958. And the Pratt-Olkin paper came out about that time. So I guess Al wrote to me, or I wrote to Al saying, oh, I noticed you have an abstract. We've both been working on similar problems. And then lo and behold, he had a postdoc at Stanford, and I had a sabbatic, and we were next door to each other. So we started talking, and then we started working on other aspects of Chebyshev inequalities, and that started our relationship. So that was 58, 59.
So you've given several instances now of how very specific pieces of research got launched, batting things around with people who you had common interest with. Can you kind of step back and generalize as to how it is that you've gotten the really best ideas that you're, the ones that you're most proud of?
Well, that's interesting. I think that, well, I think there have been several phases, different kinds of phases in my life. Like the inequalities, there was a natural hierarchy, a natural progression in the field. And so it was easier to think of that progression. But in other instances, I think applications was a very, very fundamental part of the way I saw problems.
You mean kind of the stimulus of
The stimulus. And I think it's important when you when you get involved in applications that perhaps like a detective, to see something that's interesting, that's not just answering the question, but that's interesting statistically, that will grow out of it. And I have found that to be, in my lifetime, just really a phenomenal catalytic agent, is to have a problem coming from reality. Just recently, one of my students from the School of Education, actually, works at the Marlows, Vienna, works at an eye clinic. And there are certain problems about measurements around the eye. So you have a natural circular vision, geometry that's there. And so we had a problem there. Even very early on, one of the first consultations I did was with Paul Ehrlich. This is Paul Ehrlich of Zero Population Growth. Paul actually was in the Department of Biology, and one of his students was studying symmetries in a lizard. And so here is a natural problem for multivariate observations coming from symmetric kinds of population, so to speak. And of course, one could think of other symmetries. What are the symmetries in a starfish? And so on. These are biological entities, but they generate interesting problems.
Did some of the problems that you and Al work on come out of the Boeing Labs problems?
Yes. After Al left the postdoc at Stanford, he worked in Princeton for a year, and then went to the Boeing Scientific Research Labs. And there was really a phenomenal galaxy of people. Frank Proshan, Jim Esri, Walkup, Dick Barlow visited, Bill Birnbaum, Roger Wetz was there, and I was a consultant. And there the problems came up from a reliability context. And they were natural problems. Not only do you have the reliability of a single component, but you have a system. And how do you look at bounds for getting reliability of the system? So all the questions really came out of replacement policies and so on from actual applications.
The question has to be asked, where did majorization start from?
I don't know that I can actually give you the origin, but I think it came actually when I was when I listened into Sam Collins' class on total positivity. He did not do any majorization, but somehow there were several papers that I had looked at that dealt with inequalities. And at first I thought they were inequalities from total positivity. Then I saw some results of polio, and I wrote a paper or two which used majorization. But it was in its infancy. I had no idea at that time of the potency of the idea until we started working on it, which was 10 years later. Allan and I were at the University of Cambridge in England, where we were there for a year. And we gave a seminar on inequalities, which Renyi attended. And so we would state some results, and it struck a bell for Renyi, and it struck a bell for others. Mike Perlman was there also. And somehow that indicated much, much more the potency of the ideas in majorization.
I was going to ask you one final question in the Al Marshall line, and that is that I've counted, beyond the book, you've written 30 papers with him over, first paper was 1960, so it's 30 some odd years later. Can you describe the secret to the longevity of your success with him?
Well, I don't know that I can answer that too well, except to say that I've always enjoyed collaboration. I think you have to, some people enjoy it and some people don't enjoy it. There's a certain chemistry that seemed to work well with us when we work together. Some people work together by writing individually and then sending a draft to each other. Al and I work by sitting across the table from one another. So you have to like each other to be able to sit for one full year working together, facing each other. So we would talk about all kinds of other things, and managed over the years to be able to do that. We did have a conveyor belt system, because he was in Seattle and I was at Stanford, and we needed not to get into the doldrums. And so what we tried to do was have one paper that was sort of ready for publication, and one paper that we were writing up, and then one that we're just batting ideas across. And so we'd get together approximately every 6 weeks or every 2 months, and we would try to finish what we had to in writing, and then we would sit and try to talk about new things. And so it was always constant, and we always had something to talk about. And I think that was we never sort of had a finished point when we had nothing to do. So there's always something on work in the mill, so to speak.
Ingram, let's change the track here a bit again and take you back to your student days at Chapel Hill. I mean, that was a very special time in your own life. It was a special time in the history of statistics. There were so many talented people there. Could you just tell us what it was like, maybe what got you there, and some of the remembrances you have from your days as a graduate student in Chapel Hill?
Chapel Hill was just absolutely unbelievably exciting. In addition to hoteling, there was Herb Robbins and Vasily Herfting and S.N. Roy. P.L. Sue was legally in the department, though I'll tell you about him in a moment. R.C. Bose, Nicholson was a young assistant professor. Maddow was on the faculty. Cochran was at Raleigh, not to mention a whole host of other faculty. It was exciting. And Robbins used to walk in the hall and grab somebody and say, I have an idea, would you listen in? and pull you into a seminar. And it was just a phenomenal amount of give and take. And the students had a sense of camaraderie. There were lots of students there. Now you have to remember that in 1948, when I first went there, Feller's book had not been published. That was published in 1950. So Herb gave lectures in probability from from Feller's manuscript. So there was an excitement in the beginnings of that. There was Kremer's book, and there was Kendall, and Wilkes' book, and I guess that was basically the books that we had. All other books were written subsequent to that and being developed.
What specifically got you hooked into multivariate analysis?
Well, we took, it was an interesting phenomenon there, a situation. P.L. Sue was on the faculty and was on sabbatic and went to China. Actually, as it turned out, he never returned. Walter Deemer had a PhD in educational psychology, and he was a colonel in the Air Force. And he was sent by the Air Force to study statistics. By an accident, we rented the apartment in the back of his house. So the two of us saw each other. He was in the front part of the house, and we were in the back part. And he was interested in factor analysis. And I just took a class. I wanted to take some multivariate, and I did. The class was given by Herfting based on others' notes. So we took the class, and then afterwards, because P.L. Sue did not return, Walter said, you know, this is interesting, and I thought the same, and I thought, well, why don't we try to continue? So we went to Hotelling, and we said, you know, we'd like to continue this. Is there any way? But there's no faculty giving a class. So Hotelling said, well, why don't the two of you study from previous notes? Now, Al Bowker and Ralph Bradley had taken the course with P.L. Sue, and they had notes from his class. So you see how valuable notes are. Anyhow, Hotelling said, why don't you get these notes? So Walter and I had these sets of notes, and we would meet every single day and go over the notes. And so the two of us worked together, and then we saw an opportunity to develop some of the theorems of Sue, and we worked them out and had prepared our own set of notes. So there was a final exam. So Hotelling said, well, why don't you give us a lecture on what you've been doing? So we said, fine. So Walter and I talked at that time about Jacobians of matrix transformations as the things that we were doing that was different from what was in the class, what was in the notes already. And Hotelling said, well, I think a lot of that is new. We should publish it. Well, we said, well, you know, a lot of this is based on P.L. Sue's work. So Hotelling said, well, I will write to P.L. Sue and see how he feels about what you've done. But I think Hotelling thought it was sufficiently new. Now, in 1948, the United States did not have relations with China. So Hotelling wrote to Egon Pearson and asked Pearson to transmit the letter to Sue, which he did. And in the letter, we had asked that Sue be a joint author, in fact, that he be first author. Well, eventually he replied and said that he thought what we did, he didn't have much to do with it. He thought we should publish it, but he wanted to add something because he had some ideas. So there's a section in that paper which is attributed to him, and he wrote by himself. But it was a unique situation in that the faculty was sufficiently loose to be able to do that kind of individual tailoring of a course.
Ingram, I'm going to switch gears one more time. Your travels on behalf of statistics are legendary in our profession. And I once saw you give an introduction to an informal talk where you listed your affiliation as Stanford University on Monday, Tuesdays, and Wednesdays, and elsewhere on Thursdays and Fridays.
My wife says that.
What is it about traveling or visiting that you find so attractive?
Well, I don't know that it's so true now, but earlier on, I found that there were people I enjoyed working with, collaborating on research, and that a lot of times they were elsewhere, either former students, colleagues, and so a lot of the travel was really related to working with people. So, for example, I've collaborated a fair amount with Milton Sobel. In fact, wrote a book with him. So, collaborating and meeting with Milton was that kind of thing. And it's also true of a lot of the other people I've worked with. I think the travels was a catalyst to being able to interact with people. One of the key points at Stanford was that until quite recently, almost none of us wrote joint papers with one another. It was a unique situation that, in fact, I don't know, I think the only people who wrote some joint papers, there were probably 3 or 4 in the early days. Rupert Miller wrote a joint paper with Lieberman, and I think maybe one Chernoff and Moses. But by and large, the Stanford faculty did not, did not write papers with each other. Quite to the contrary, what we did was invite others from elsewhere to come and visit, and we worked with them. So the result was we had a small faculty, but they reached out by having visitors working in areas. And I think that was a critical point in expanding a small group of people who might work together a lot to expanding the horizons and working with people from all over the world.
But these travels got you involved with lots of other things beyond research in terms of being involved with journals and
Yes.
getting involved with governmental committees and moving into this more statesman-like role that you've taken on over these last number of years.
Well, I don't know. I guess early on, people like Wilkes and Neyman had a lot of influence on me. I don't mean in the scientific way. I mean, they were giants in their own in their science, but it did seem to me that individuals could have a profound effect on the field. And there's just no question that Neyman created a statistical empire in the most positive sense in the Bay Area. He had the Berkeley Symposium, brought all kinds of people. And I think Wilkes had a similar effect on the East Coast and elsewhere. And somehow, perhaps I was interested in doing that. Perhaps I was good at it. I don't know the reasons, but somehow it seemed to me that that was an important part of giving back to the field and making sure that students continued. Also, I think when you're brought up having a good background in graduate school, you sort of want to pass it on. And I really had a great time both at Columbia and at Chapel Hill.
There must be something about the strength of our institutions, the cops, the cats, and all of these things that you must believe in firmly because you've devoted so much of your time to making sure that these institutions not only survive but flourish.
Well, it's interesting about whether institutions survive in perpetuity and what it takes to make them survive in perpetuity. I really felt that journals, at one time felt very strongly about journals being important both for the lifeblood of the profession and for young people to progress. And there was a lot of hostility when we split the annals of mathematical statistics into two journals, Annals of Statistics and Annals of Probability.
You were the last editor of the Annals.
I was an editor of the Annals of Mathematical Statistics and effected the break.
Yeah.
And then Ron Pike became editor of the Annals of Probability. But people felt that it was a splintering of the profession and it would be detrimental. Of course, in retrospect, it's hard to imagine now that those two journals could possibly be one journal. I mean, the amount of articles is just beyond being able to cope with that kind of situation. And then statistical science was another important area. That Maury de Groot and I would talk many times about how do we get people not so mathematical to be interested in statistics. And we felt that perhaps something like the statistical science would be worthwhile. And we put a lot of energy into that.
Was that a hard sell to the IMS? Or?
That was a hard sell. We were very fortunate in that Bruce Trumbo was treasurer, and I had just been president, and so we were able to convince the council. Bruce Trumbo, as treasurer, had to say that the finances could handle it, and that was a critical point, because if there's a negative view of the finances, it usually kills that kind of project. So we felt very comfortable that it would succeed.
Ingram, before we run out of time here, there's just one institution that we would be totally remiss if we didn't raise here explicitly. You were especially influential in the establishment of NIST, the National Institute of Statistical Sciences. Can you tell us just for a minute or two about your vision and the role you played in setting it up?
Yep. We had at that time, shortly before that, there was a panel on interdisciplinary research. I had felt all along that interdisciplinary research is really going to become the lifeblood of statistics at some point. Whereas mathematics of statistics had been the lifeblood during the 50s and 60s, I thought we were moving definitely into applications. So this panel discussed interdisciplinary research in terms of statistics. The panel was supported by the National Science Foundation, and it was an IMS venture. Towards the end of that panel report, I felt that unless we institutionalize this and have a mechanism for people to get into interdisciplinary research, that it would be difficult to affect in the university environment, because the departmental structure is antagonistic to interdisciplinary research just by the nature of its work. So we put into the report that ultimately there should be an institute, a National Institute of Statistical Science. After that report came out, it was dormant for a while, and then we were able to point to that and use the fact that it had been supported by NSF, that perhaps we should begin to think about it. And then we started taking steps to actually institutionalize it.
Do you have some thoughts about where NIST is now and where it might go in the future?
Well, it's been in existence for half a dozen years. They've done a lot of projects. of an interdisciplinary nature. They've been able to get scientists from other fields to interact with statisticians. And what's critical is they've had a lot of young people as postdocs. And I think that as time goes on, it will become better and better known, and more of an opportunity for statisticians who want to get involved in interdisciplinary research to spend time. And that's what I'm hoping, is that it will become somewhat of a mecca for work in interdisciplinary research.
Good. Thank you, Ingram. Well, we are indeed about to run out of time here, and before we wrap up, I'd just like to thank the University of Connecticut and Pfizer and the whole team of people that have been working behind the scenes here that have made this casual chat here work so nicely. And in particular, Ingram, I'd like to thank you for sharing your story with us. We could have gone on for hours, as I think most of the people here realize. I'd also like to thank you on behalf of all of your colleagues in the profession for all the contributions that you have made to the success that we really cherish. And quite frankly, I think we're expecting much more out of you, and I think that we could get together in another 5 or 10 years, we'll be able to do this all over again and tell a rather different story. So thank you, Ingram.
Thanks, Ingram.